Hey everybody, and welcome to Camp GIT. I'm Katie.
I'm Caitlin.
And I'm Elise.
And we'll be your camp leaders for the next 3 days as we journey through the gastrointestinal tract. Buckle in, but first, let's grab a bite. To begin, the whole gastrointestinal system is made of two major parts, the foregut and the hindgut. Our first stop, the foregut. A horse's diet mainly consists of hay, haylage, or grass. Talk about fiber. And unlike you and I, who can eat big meals only a few times a day, horses need little meals multiple times a day and should constantly be able to graze. As we get picked up into the horse's mouth, we see the tongue, teeth, and salivary glands. If you look closely, you'll see something very important start to happen, something that only happens when the horse is chewing. The mouth begins to create saliva. Horses can produce about 100 liters of saliva a day. This saliva is so important because it contains small amounts of alpha amylase enzymes. These very small guys help to break down the horse's high fibrous diet. The saliva then helps to lubricate the esophagus as the food is swallowed, and we move on to our next step.
Our second stop of the day is the esophagus. It's a long tube composed of 3 sections that connects the mouth to the stomach. The first 2 parts, cervical and thoracic, are made of skeletal muscle, meaning the horse controls the muscle contractions. The last section, abdominal, is made of smooth muscle, meaning the horse's body automatically controls its contractions. Peristalsis, wave-like contractions, push the food to the stomach. The esophagus is able to expand due to longitudinally oriented folds. A fun fact about horses is that they are unable to vomit due to the acute angle at which the esophagus meets the stomach.
We are now entering the stomach. A hormone within the distal part of the stomach is gastrin. It stimulates acid secretion in the stomach and gastric motility. The stomach is located between the 9th and 15th ribs on the left side of the abdomen. The stomach makes up 10% of the horse's GI tract. There's 3 parts: storage of feed, mixing of gastric juices, and breakdown of feedstuffs. It can hold 8 to 16 liters. We will remain here for 20 minutes. Some particles will remain for 48 hours. Small frequent meals are better for the horse. Horses have the smallest stomach in relation to their huge size. The stomach is divided into non-glandular, which is the upper part or squamous region, and glandular. These glands protect the stomach from the low pH. Gastric splashing and ulcers are a bad thing, so those frequent meals will help. Ulcers also happen from change in diet, parasites, stress, and strenuous exercise. PGE2 inhibitors like bute and NSAIDs block PGE2, which is the main pain chemical. This lowers mucus production in the stomach, which could lead to increased risk of ulcers. The pancreas has exocrine secretions vital to digestion of fat, starch, and protein. The liver has bile secretion, which is continuous due to the horse having no gallbladder. Next stop, the small intestine.
Our next stop is the small intestine, making up about 30% of the horse's gastrointestinal tract. At 70 feet long, we're in for a quick and twisty ride. We'll be moving at about 1 foot per minute. All of these finger-like projections are called villi, and they increase the surface area of the small intestine. First, we enter the duodenum, where enzymes like pancreatic amylase and bases work to neutralize and break down the acidic contents of the stomach. The duodenum is only 1 meter long, but its job is so important as it reduces the risk of colic later on by breaking down fat with the help of bile. Next, we enter the jejunum, a common location of torsion colic. The jejunum is 20 meters of twists and turns. It is super flexible and has an elongated mesentery, allowing for all of these windy passages. Finally, we have the ileum, which is only 45 centimeters long. It has a thick muscular wall that delivers digesta into the cecum. An easy way to remember all the parts of the small intestine is by remembering DJ ileum.
Welcome and congratulations, you've officially made it to the hindgut. Now, on the right side of the horse's abdomen, we have made it to the cecum. Sometimes if the cecum is filled with too much gas, this side of the horse will look swollen. We are in the house of fermentation. This is where it all begins, and we'll be here for about 5 hours. The cecum is 1.5 to 2 meters long, making up about 12 to 15% of the horse's gastrointestinal tract. It can hold about 30 liters of fluid and feed, and it's blind-ended, meaning the way we came in is the way we're going to have to go back out. While we're here, the main purpose of the cecum will be fluid absorption. Fun fact, did you know the cecum can absorb the entire amount of a horse's body fluid in one day? Muscular contractions in the cecum mix together feed, fluid, and microorganisms. Microbial digestion takes place and volatile fatty acids are created. These will be used later on for energy. Let's follow this mixture to the exit. We'll go through the decocolic opening and towards the colon.
Welcome to the large colon. This structure is 25 to 30 centimeters in diameter, located in the ventral belly side of the abdomen from flank area to rib cage. This is the beginning of the large intestine. Its primary function is cellulose fermentation. Its three sections are right dorsal colon, transverse colon, and descending colon. The right dorsal colon has a wide diameter and has a strong attachment to the mesentery. The left dorsal colon is not directly attached to the mesentery wall. Watch out, this is the danger zone. A lot of displacements and twists happen here. The process begins in the right side of the ventral colon. The ingesta is then mixed so plant fibers can be retained until it's fully digested. The fluid is removed from the digester and returned to the body water compartment. Ingesta then moves from the left side of the ventral colon via sternal flexure. Ingesta then moves to the left side of the flank region. Now the diameter is decreasing, another danger zone for a nasty impaction.
This area is known as a pelvic flexure. Muscles move in the opposite direction because they are shocked at the particle size. This is one of the many reasons why impaction is common here. Colic is the #1 cause of premature death in horses. Some risk factors include infrequent large meals, abrupt changes in diet, high grain, low forage diets, accumulation of sand in the small intestine, and parasites. Volatile fatty acids are produced in the colon as a byproduct of fermentation. Then they are absorbed into the bloodstream and used for energy.
3 days later.
It's been quite some time. We've gone through the reabsorption of water in the small colon and have now created fecal balls. The rectum is our last stop. Matter accumulates here until ready to be released, and through the use of voluntary muscle, the rectum pushes the fecal balls out of the anus. And that is the final step in our gastrointestinal journey. Wow, look how far you've come. You started in the mouth, moved through the fore and hindgut, and I don't know about you, but we're pooped. We hope you had so much fun joining us at Camp GIT. Y'all come back now.